Hello everyone, myself Soumya Vijay, Assistant Professor, Department of ECE, SJBIT. In this session, I will be discussing about the Module 1 topic of microwave and antennas. This module is about microwave sources and transmission lines. Let us first start with the introduction to the microwave. For this, we need to first get a brief discussion with respect to the electromagnetic spectrum. As we know, in the electromagnetic spectrum, we have got the frequency ranges starting from the DC to the values like 3 Hz, 3 kilohertz, 30 kilohertz, 3 gigahertz, like etc. frequency ranges, and these frequency ranges are named according to the applications as well as the frequencies of operation. They are named as low frequency, very low frequency, high frequency, like that. And whenever we have got the region in the DC to 430 to 750 terahertz, we call it as non-ionizing region, and the remaining they come into the category of ionizing. And as we can see here, as the frequency is being increased from DC to this, the frequency waveform, as you can see here, the frequency actually is increasing, and the frequency is actually given by the expression C by lambda. When the wavelength is more, the frequency is less. So as you can see, in the lesser frequency ranges, 3 Hz, 3 kilohertz, 30 kilohertz and all, there is more wavelength. The wavelength is more and the frequency is less, but as you go further, the frequency is more and the wavelength will be less. And accordingly, as you can see in this slide, the applications with respect to these frequency ranges are also being mentioned. Whenever we go for DC to 3 Hz, we use that for geomagnetic and sub-ELF sources, in EMF sources, earth and subwaves applications. And when I tell about extremely low frequency, that is 3 Hz to 3 kilohertz, they are actually used for AC power applications. Next, very low frequency means 3 kilohertz to 30 kilohertz, we are using that for CRT monitors. Next comes the RF, radio frequency range, that is 30 kilohertz to 3 gigahertz, 30 kilohertz to 3 gigahertz. This frequency ranges is usually used for the mobile, that is AM or FM, and similarly it is used for TV, and it is used for cell phone or PCS. And after this, we have got the next frequency ranges, that is 3 gigahertz to 300 gigahertz, which actually they come into the category of radio frequency only, but usually we just in some cases we segregate that as microwaves. These are the frequency ranges which are present in the gigahertz range, and they are mainly used for cell phone applications as well as microwaves and satellite applications. And this module or this subject is basically related to these microwave signals, their generation, their operation, their analysis as well as their applications. After this, we have got the next range, that is infrared range, is 300 gigahertz to 430 gigahertz, as well as after visible spectrum is there. Next we have ultraviolet, then we have got X-rays, which are used for medical field for finding getting the X-rays. Next we have again we have got gamic or cosmic rays. These are actually the radioactive sources, like this. This is electromagnetic spectrum ranging from lower frequency to higher frequency, and in this, in the gigahertz, 3 gigahertz to 300 gigahertz, whatever frequency range is there, that comes to the category of microwave, which is actually used for cell phones, a microwave oven, as we can see, we are using in that in our homes. This can be called as a household application. Similarly, in microwave and satellite applications, these frequency ranges are being used. Let us now segregate the RF bands according to the IEEE standard. RF bands according to the IEEE standard. In this, we actually correspond the bands, we actually segregate the bands as a letter. We give that in terms of a letter designation. We call this as L band, and this L band it comes in the frequency range of 1 to 2 gigahertz, and the wavelength is about 30 to 15 centimeter. In this case, as you can see, the wavelength is it is actually more, and the frequency is actually just less. It is in terms of 1 to 2 gigahertz. Now, when you go for S band, the frequency increases further. It is in the range of 2 to 4 gigahertz, and the wavelength is in the range of 15 to 7.5 centimeter. Next comes the C band. For C band, the frequency range is 4 to 8 gigahertz, and the wavelength range is 7.5 to 3.75 centimeter. Next comes the X band. For X band, the frequency range is 8 to 12 gigahertz, and the wavelength range is 3.75 to 2.5 centimeter. Next comes the KU band. For this, the frequency range is 12 to 18 gigahertz, and the wavelength range is 2.5 to 1.67 centimeter. Next comes the K band. For K band, the frequency range is 18 to 27 gigahertz, and the wavelength range is 1.67 to 1.11 centimeter. Next is Ka band. For Ka band, the frequency range is 27 to 40 gigahertz, and the wavelength range is 1.11 to 0.75 centimeter. Next is U band. For U band, the frequency is 40 to 60 gigahertz, and the wavelength is 7.5 to 5 millimeter. Next we have V band. For V band, frequency range is 60 to 80 gigahertz, and the wavelength is 5 to 3.75 millimeter. Now, as the frequency is increased more, so we have got wavelength has to be in the range of millimeter. Next we have W band. The frequency range is 80 to 100 gigahertz, and the wavelength range is 3.75 to 3 millimeter. Like this, the radio frequency bands is being divided into many number of bands with different frequency ranges and different wavelength. This is one more representation for the electromagnetic spectrum with respect to the frequency as well as with respect to the wavelength values. The frequency hertz starting from 10.8 to 10.19 hertz, and the wavelength starting from 1000 meter to 0.1 amps. Here, as you can see here, initially we have got long waves corresponding to then radio TV applications. Next we are using in microwave applications. Next is infrared, next visible, next ultraviolet, X-rays, gamma rays, and one of the spectrum, visible spectrum, is being shown here. This visible spectrum is having the spectrum ranging from 700 nanometer to 400 nanometer, starting from red to the violet or the purple color. And coming to the radio TV, here there is again divided into the frequency 50 megahertz to 1000 megahertz, and the bands is very high frequency for FM, very high frequency. Next we have FM, again very high frequency 7 to 30. Next upper to that we have ultra high frequency. This is the most important table which actually gives the radio frequency bands with their frequency ranges as well as the applications. This is most important with respect to the exam point of view. Here in the first column we have got the name of the radio frequency band. Next we have second column has frequency range, and in the third column we have got applications in which this radio frequency is being used. The first one is low frequency, named as LF. It is in the frequency range of 30 kilohertz to 300 kilohertz. It is used for in time standard application and in navigation application. Next we have medium frequency MF. This is used in 300 kilohertz to 3 megahertz. This is used in the AM radio applications. Next we have high frequency HF. This is in the frequency range of 3 megahertz to 30 megahertz, and the application is amateur radio applications. Next is a very high frequency VHF. The frequency is 30 megahertz to 300 megahertz, and the application is FM or TV broadcasting. After this, we have ultra high frequency UHF. The frequency range is 300 megahertz to 3 gigahertz. The application is cell phones, WLAN and GPR. After this, we have super high frequency SHF, and the frequency range is 3 gigahertz to 30 gigahertz, and the application is satellite and 5G mobile. Then we have extremely high frequency, that is EHF, or it is also called as MMW, and the frequency is 30 gigahertz to 300 gigahertz. Application is imaging or detection application, and it is used in 5G mobile as well. And coming to the last one, that is tremendously high frequency THF, tremendously high frequency. This is used in the frequency range 300 gigahertz to 3 terahertz, and the application is high resolution microwave imaging, high resolution microwave imaging. Now we need to discuss about one more tabular representation with respect to the IEEE standard. With respect to IEEE standard, the first column has got band designation, next frequency range, and what is the naming that is been given to that. The first is high frequency. The frequency range is 0.003 to 0.03 gigahertz. It is high frequency range. Next we have VHF, 0.03 to 0.3 gigahertz. It is a very high frequency range. Next is UHF, 0.3 to 1 gigahertz. It is ultra high frequency range. Next we have L star. Here L star is indicating what the custom MMIC supplies, standard MMIC, microwave integrated circuits. L is in the frequency range of 1 to 2 gigahertz, and it is long wave. S 2 to 4 gigahertz, and it is corresponding to short wave. C 4 to 8 gigahertz, and it is a compromise between the S and X. Next is X. It is having the frequency range 8 to 12 gigahertz. It is used in WW2 for file control, X for cross, as in crosshair, and exotic. Next we have KU. It is 12 to 18 gigahertz, and it is named as Kurs Anders. Next K 18 to 27 gigahertz, Kurs. Kurs means short. Next we have KA 27 to 40 gigahertz. The meaning of KA is Kurs above. Next is V. V is 40 to 75 gigahertz. Next we have W, 75 to 110 gigahertz. W follows V in the alphabet. Next MMRG, MMRG 110 to 300 gigahertz, and it is in millimeter. Now let us discuss about advantages of the microwaves. The first most important advantage is the increased bandwidth availability, and second one is improved directivity properties, and third one is fading effect and reliability, fading effect and reliability. Fourth one is power requirements, and fifth one is transparency property, transparency property. Let us know the advantages again. The first most important advantage is increased bandwidth availability. Second is improved directivity properties. Third is fading effect and reliability. Fourth is power requirements. Fifth is transparency property. Now let us know the applications and frequency bands. When I tell FM radio, the frequency is 88 to 108 megahertz in specifically. When I tell CDMA, it is operating in 824 to 890 megahertz. When we tell GSM 900, it is operating in 890 to 915, as well 935 to 960 megahertz. GPS is 1575 plus or minus 10 megahertz. GSM 1800 is 1710 to 1780 and 1810 to 1880 megahertz. And coming to the 3G, it is operating in 1920 to 1980 as well, 2110 to 2170 megahertz. And coming to 4G, 2300 to 2400 megahertz. And Wi-Fi is 2400 to 2483 megahertz and 5.2 or 5.8 gigahertz band. Satellite and defense communications, HF2 millimeter wave. Let us have the overview of microwave applications. They are used in almost all the field, in civil, military as well as medical applications. In civil, for wireless communications, vehicle collision avoidance, in remote sensing. In military, aircraft safety and navigation, radar, missile guidance and control. Medical, cancer, tumor detection, medical diagnosis as well as therapy. This is a diagram of the microwave communication systems. This is having both transmitter section as well as the receiver section here. In the transmitter section, we have got the modulating signal as well as the carrier signal, because the signal that has to be transmitted, as we have learned in communication, the basic communication system has got the modulator. In order to modulate the signal, in order to convert that low frequency signal into high frequency signal, I need to modulate. So, we have got a modulating signal, a low frequency signal, carrier signal, a high frequency signal. After modulation, it will be amplified and then it will be sent to the impedance matching network. Then there is antenna here. From the antenna, it will be transmitted to the receiver section. In the receiver section, we are having a RF amplifier, the radio frequency amplifier. Then we are having a mixer, which actually combines that RF signal with the local oscillator signal, and that results in the signal which has to be filtered and then amplified again. Finally, we need to demodulate that signal and get the signal and to the display device or to the speaker. This slide is highlighting the microwave components as well as the systems. When I tell passive microwave components, we are having transmission line, we are having antenna, power divider or combiner, coupler, filter as well as attenuator. When I tell active microwave components, we have got a amplifier, microwave amplifier, a oscillator, a mixer, RF switch as a phase shifter. And when I tell a complete microwave system, the example is mobile phone jammer or repeater, RFID, RF transceiver, GPS, GSM modules, radar, RF energy harvesting as well as microwave equipment and high power microwave system. So, this gives us an idea of what are the passive microwave components, what are the active microwave components. Here active in the sense these components are actually the one which generate the signal, but the passive components, they are not involved in any generation of the microwave signal, they are used in the transmission of the signal or the processing of the signal. And this microwave system is the system which is actually made up of these microwave components in order to generate as well as send and receive the signal. This is about the introduction to the microwave. We discussed about electromagnetic spectrum, what are the bands available in the electromagnetic spectrum, what is the microwave frequency band, and what is the frequency range and application of each band. What is the block diagram of the microwave communication system, what is microwave passive component, what are active components as well as microwave system examples. Thank you.